अस्सलाम वालेकुम फ्रेंड्स, आई एम इशफाक रियाज। आज का जो हमारा टॉपिक है वो है कॉम्बिनेशन ऑफ रेजिस्टर्स। जी हाँ, ग्रुपिंग ऑफ रेजिस्टर्स पे हम बात करेंगे। इससे पहले मैं कॉम्बिनेशन ऑफ रेजिस्टर्स पे आऊँ, आई विल एक्सप्लेन व्हाट बेसिकली ए रेजिस्टर इज। So resistor is basically a conducting substance which has the resistance of a desired value. For example, you know the circuit symbol of this very resistor like this, having ups and downs. Basically this resistor, it has a resistance, and the resistance is basically the electrical property of the resistor, and you already know resistance is simply the obstruction or opposition or hindrance posed by the conductor to the flow of current. So that's why it is represented by these hills, ups and downs, resist, obstruct. So this is basically a resistor. Now the question is, why do we combine these resistors? हमारे पास जो सर्किट्स होते हैं, चाहे रेडियो में होता है, टीवी में होता है, या मुख्तलिफ इलेक्ट्रिकल सर्किट्स होते हैं, उनमें हमें करंट की ज़रूरत पड़ती है. सो टू वेरी द करंट वी हैव टू वेरी द रेजिस्टेंस, बिकॉज from Ohm's law, V is equal to IR. From this, I can write I is equal to V by R. So, current, apart from depending upon the potential difference, it also depends upon the resistance of the circuit. So if we increase the resistance, current will get decreased, and if we decrease the resistance, current will get increased. So current will vary, current will change with the change in the resistance. ये resistance हम change कैसे कर सकते हैं? दो तरीके हैं इसके लिए. एक तो है series grouping and number two parallel grouping of the resistance. So resistors are grouped together, rather combined together to get the required resistance, to get the desired resistance. और दो तरीके मैंने आपको बताए, resistors in series and resistors in parallel. Now here we will discuss resistors in series. So series grouping of resistors. कब मैं कहूँगा कि मेरे पास जो रेजिस्टर्स है ये सीरीज में कनेक्टेड है? कब बताऊँगा? मैं आपको डायग्राम के जरिए दिखाता हूँ. लाइक दिस, फॉर एग्जांपल, दिस इज ए रेजिस्टर R1, दिस इज अनदर रेजिस्टर R2, and this is one more resistor R3. So when they are connected from end to end, yani when the resistors are connected from end to end, they are said to be in series. Or I can say it like this. For example, this is resistor R1, this is another resistor having resistance R2, and this is third resistor having resistance R3. So when they are connected end to end, we say that the resistors are connected in series. ऐसे में भी कह सकता हूँ, when same current flows through all the resistors. For example, the battery sends the current I. Same current I will pass through R1. It will also pass through R2. And the same current I will also pass through R3. Why? Because current does not have any other path to follow. So, same current flows through all the resistors. Now, let's try to calculate the expression for the net resistance offered by these resistors, by this combination of resistors. And for that, we will use Ohm's law. So V is equal to IR. Now going back in this very diagram, we have, since the resistances of three resistors are different, so accordingly their potential differences will be different. Now, from the diagram or from Ohm's law, V1, let V1 be the potential difference across R1. So this will be equal to I into R1. Now V2, potential difference across R2, it will be equal to I into R2. And what about V3? This will be the potential difference across R3. So this will be equal to I into R3 because I is same in all the three resistors. Now, Let me suppose that this combination of resistors, I mean this series combination of resistors, it is equivalent to a single resistor of resistance Rs, to which same potential difference is applied, I mean V, and same current I flows through this very resistor, I mean Rs. Now, from Ohm's law, V will be equal to, that is potential difference, total potential difference applied, that will be equal to I into Rs. Now, see, in this very diagram, total potential difference applied, it will be equal to V1 plus V2 plus V3. So, total potential difference applied, it will be equal to V1 plus V2 plus V3. This is the total potential difference applied across the series combination. Now let me substitute the values. Now V के बदले में क्या लिखूंगा? I into Rs. What about V1? This is equal to I into R1. What about V2? I into R2. And what about V3? I into R3. Now, so I into Rs is equal to, let me take I common from RHS. So this is R1 plus R2 plus R3. So I and I will cancel out. What remains there is Rs, that is the resultant net effective or the total resistance in series combination. So it will be equal to R1 plus R2 plus R3, which is the law of combination of resistors in series. So the statement of this very law will be the net resistance or the total resistance or the effective resistance when a number of resistors are connected in series is equal to the sum of the individual resistances. So this is what the statement of law of combination of resistors in series is all about. Now let's try to write some special points about the series combination. So the first point will be, for two resistors, Rs will be equal to R1 plus R2. Now, what about for what about for n resistors? Rs will be equal to R1 plus R2 plus so on up to n times. So I will write it like this. This Rs is equal to summation I runs from 1 to n Ri. So this will be sum of the individual resistance. Now if these resistors are identical, I mean each of the resistor is having the same resistance, let it be equal to R. So Rs will be equal to R plus so on up to n times. So this will be equal to n times R, that is number of resistors into resistance of one resistor. Now let me illustrate it with the help of an example. For example, if we have two resistors, let R1 be equal to 2 ohm and R2 be equal to 3 ohm. When these two resistors are connected in series, I will get the net resistance will be equal to 2 plus 3, that will be equal to 5 ohm. And see, this 5 ohm, it is greater than 3 ohm, it is also greater than 2 ohm. So this resultant resistance is greater than the greatest of the resistances. So you can easily see here that the net resistance increases in series combination. So when will we use this very combination? If the net resistance is to be increased or the total or the current is to be decreased. Now one more point about this series combination is, since V is equal to IR, or I will write it V1 is equal to I into R1. Since I is constant, I will write V1 is directly proportional to R1. What I mean by this expression is that potential difference of each resistor is directly proportional to the resistance of that very resistor. And one more point, last point about the series combination will be, look at this very figure. The position, rather relative position of the resistors does not affect the total value of the resistance. I mean, wherever you place the resistors R1, R2 and R3 in series, R1, R2 and R3 in series, still the total resistance will be equal to R1 plus R2 plus R3. So the value of the resistance is not affected by the relative position of the resistors. Hope you enjoyed this lecture, and we will be discussing resistors in parallel in the next lecture. Goodbye. So we got